Habt ihr diese Funkgeräte gesehen? Die sind unglaublich.
Und der ganze Treibstoff. Woher bekommen Sie das?
Das ist doch Wahnsinn. So etwas habe ich noch nie gesehen.
Mid-February 1943, Sidibou Zid, Tunisia. The captured M4A1 Sherman tank rolled to a stop on the desert sand, the American star still faintly visible beneath a hastily painted German cross. Officers from the Heavy Panzer Battalion 501 gathered around the prize, notebooks in hand, already anticipating what this single, intact operational tank could reveal. Captured during the Battle of Sidibou, this Sherman would trigger a crisis of confidence among German engineers that echoed through tank development programs for the rest of the war. The mathematics of armored warfare were about to be rewritten, not through thicker armor or heavier guns, but through something the Germans had never prioritized: automotive reliability that simply refused to fail. The tank bore the name War Daddy 2 on its hull. Serial number USA 3067641, built by Lima Locomotive Works, belonged to Company G of the 1st Armored Regiment, 1st Armored Division. German reconnaissance units drove the Sherman 350 kilometers across the harsh North African terrain to the port of Sfax, a journey of 4.5 days. Every kilometer revealed unexpected truths about American industrial capability. The engine never overheated. The transmission never failed. Final drives remained consistent. German crews, accustomed to frequent mechanical stops, watched in growing unease as the enemy tank simply worked without complaint under conditions that would have disabled their own machines. At the port, War Daddy 2 was loaded onto a cargo ship bound for Germany. Orders from the Army Weapons Office were clear. The tank must reach the testing facility at Kummersdorf intact. German intelligence had received fragmentary reports on American tank production, but seeing the machine firsthand made the statistics real. The Sherman represented mass production on a scale Germany could not match, built with engineering principles Germany had never mastered. Spring 1943, Kummersdorf Proving Ground, Brandenburg, Germany. War Daddy 2 rolled off the transport rail car, bearing the designation Zugfahrts 259 and German license plate WH058941. Engineers, meticulously prepared, marked armor thickness and angles across the tank for evaluation. Kummersdorf served as Germany's primary testing facility for both domestic and captured Allied equipment. Specialists measured every component, photographed each part from multiple angles, and documented construction techniques that were astonishingly straightforward compared to German practices. The transmission immediately drew attention. German tanks used straight-cut gears requiring precise tolerances and frequent maintenance. The Sherman employed herringbone-cut gears, distributing stress across multiple teeth simultaneously. Standard in American automotive manufacturing since the 1930s, this design offered durability with minimal maintenance. German engineers had considered herringbone gears too difficult to mass produce, but the Americans were doing it by the thousands. Automotive trials began, replicating battlefield conditions. Engineers monitored engine temperature, fuel consumption, and transmission behavior. After each test, components were disassembled to inspect wear patterns. The results contradicted every assumption of German armored doctrine. The Sherman excelled in operational endurance, performing consistently where German tanks routinely failed. The Sherman's 5-speed manual transmission, with synchronized gears from 2nd through 5th, eliminated the need for double clutching during normal operations. German tankers required extensive training to operate transmissions safely, but American design assumed that ordinary soldiers could operate tanks reliably with minimal instruction. The Continental R975 radial engine maintained consistent performance across conditions that would cripple German engines. Air filtration handled desert sand with ease. Every system prioritized practical functionality over theoretical optimization. June 6th to 7th, 1943, Hillesleen Artillery Range. Reich Minister Albert Speer presided over an armament demonstration featuring War Daddy II, the Panther Ace Diem, and the Ferdinand tank destroyer. The Sherman climbed inclines with ease, its transmission shifting smoothly, engine power consistent. The Panther struggled, the Ferdinand stalled, embarrassing recovery crews in front of senior officers. Speer noted the Sherman's superior cross-country mobility, confirming reports from the 26th Panzer Division about its exceptional performance. Publicly, Das Reich praised the Sherman as a product of North American industry, highlighting serial construction and innovative features like the gyro-stabilized gun. Privately, alarm spread among German engineers. American tanks weren't just adequate, they were superior in reliability and operational endurance. At Kummersdorf, testing continued through 1943. Extended trials documented operational ranges over 2,000 kilometers before major maintenance, a figure far exceeding early Panthers. Transmission efficiency, synchronized gears, and herringbone final drives proved far more reliable than German equivalents. Panthers and Tigers were prone to mechanical failure under far lighter loads. German field reports confirmed the data. Panthers averaged 40% operational readiness in 1943, sometimes as low as 16% during Operation Citadel at Kursk. Shermans consistently outperformed these metrics. Captured Shermans reinforced German observations in combat. Unlike Soviet T-34s, Shermans required no modification and operated reliably. Letters and reports from German crews expressed astonishment at their dependability. Even the complex Chrysler A57 multi-bank engine proved easier to maintain than German alternatives. January 1945. The Panzer Commission officially admitted catastrophic failure rates in German tanks. Mechanical unreliability prevented tactical effectiveness, forcing crews to abandon vehicles. Meanwhile, Shermans captured, or supplied via Lend-Lease, maintained operational capability, confirming what Kummersdorf had already proven. American industrial maturity, mass production, and practical design principles outweighed German technical sophistication. By mid-1943, German engineers had documented the stark contrast between their vehicles and the Sherman. Reports detailed superior powertrain performance, easier maintenance, and design margins that allowed upgrades and battlefield reliability. German industry lacked the capacity to replicate these principles under wartime conditions. American mass production expertise, honed in civilian automotive manufacturing, gave the Sherman a decisive advantage. War Daddy II, tested exhaustively at Kummersdorf, symbolized more than just an enemy tank. It proved that Germany had already lost the industrial war. Reliability, maintainability, and operational availability, not firepower or armor, determined success in armored warfare. American design philosophy, built on decades of automotive experience, consistently won where German specifications failed. The Sherman did not win World War II through technical superiority alone. It triumphed through industrial reliability, operational endurance, and practical engineering. Kummersdorf's exhaustive testing revealed the reality that German engineers and officers could not ignore. In modern mechanized warfare, the machine that works is far more powerful than the machine that merely looks superior on paper. When German engineers captured an American M4 Sherman tank in Tunisia in February 1943, they expected a mediocre, easily broken machine. What they found instead at the Kummersdorf testing facility would overturn every assumption about tank design and reliability. This is the remarkable true story of War Daddy 2, serial number USA 3067641, and how it exposed the fatal weaknesses in German armored engineering. While Panther and Tiger tanks dazzled with firepower and thick armor, they constantly broke down, achieving only 20 to 40% operational readiness. The Sherman, in stark contrast, simply kept running. German test reports revealed shocking truths. Sherman transmissions used herringbone gears that lasted thousands of kilometers, while Panther transmissions failed after mere hundreds. American automotive engineering, honed over decades of civilian car production, produced tanks that could be maintained by mechanics with basic training. German tanks demanded specialists and constant repairs. By January 1945, the Panzer Commission documented catastrophic failures: 500 defective Panzer IV final drives, 370 faulty Panther drives, and 100 Tigers abandoned, not to enemy fire, but mechanical breakdown. Even Albert Speer admitted Sherman superiority after the June 1943 Hillersleben demonstration. This meticulously researched documentary uncovers how 49,324 reliable Shermans overcame technically superior yet mechanically disastrous German tanks. Explore classified German test results, authentic Das Reich newspaper accounts, and verified military reports proving that in war, reliability beats raw specifications. Keywords: World War II tank warfare, Sherman tank versus Panther, German tank reliability problems, Kummersdorf, proving ground secrets, untold story of American industrial might, armored warfare innovation, World War II engineering triumph, February 20th, 1943, north of Kasserine Pass, Tunisia. German tank commanders would never forget the sight that morning. Sherman tanks moving with a precision that violated every principle of German armored doctrine. Across broken terrain, through smoke and dust, 5 Sherman tanks advanced on German positions with coordination that seemed impossible without visual signals. No flags, no flares, no dispatch riders running between vehicles. Yet each Sherman moved as part of a single organism, covering blind spots the others could not see, each crew fully aware of their comrades' positions. German Panzer IVs equipped with Fug 5 radios struggled to maintain contact. Commanders shouted over static, their 10-watt transmitters barely reaching beyond a few hundred meters when tanks were moving. Many vehicles only had receivers, unable to report sightings or call for support. Meanwhile, Sherman crews operated with technology that the Germans could scarcely imagine. Frequency modulation radios, crystal-controlled precision, 25 watts of power, cutting through engine noise and battlefield chaos like a scalpel through paper. 8,000 miles from Detroit, the US had begun to forge the most decisive technological advantage of the war. Not in armor thickness or gun caliber, but in electromagnetic waves linking each tank into a cohesive network. The transformation began on July 22, 1941, when the U.S. Army standardized the SCR-508, SCR-528, and SCR-538 for all medium tanks. While German forces advanced through the Soviet Union relying on limited radio communication between command vehicles, 1941, American engineers at Galvin Manufacturing, later Motorola, perfected frequency modulation technology that rendered German radios obsolete. The team included Daniel E. Noble, who envisioned FM in combat vehicles, and Henrik Magnowski, the lead RF engineer who overcame the challenge of installing complex electronics in a moving, vibrating tank environment. Their creation, weighing 181 pounds, transformed every Sherman into a node in the first true battlefield network. The BC-604 transmitter output 25 watts, more than twice the FUG-5's 10 watts, operating on 20.0 to 27.9 MHz with 10 crystal-controlled channels. The dual BC-603 receivers allowed commanders to monitor multiple frequencies simultaneously, a capability that proved decisive in combat. Frequency modulation eliminated static and interference that plagued German AM systems. Every spark plug, every motor, every track movement in German tanks generated noise, while Shermans communicated clearly even under artillery fire. November 8, 1942. Operation Torch. The 2nd Armored Division landed near Safi and Fidala with SCR-508 radios ready to prove their superiority. The Afrika Korps, Germany's most experienced armored force, suffered under strict communication limitations. Only 1 or 2 tanks per platoon could transmit and receive. The rest had receivers alone. German platoons relied on a rigid chain of command. When command tanks were destroyed, entire units lost cohesion. American tanks, however, could all perform command functions, giving them unprecedented tactical flexibility. February 14th to 24th, 1943, Kasserine Pass. Though tactically a German victory, the battle exposed the Americans' invisible advantage. Scattered elements of the 1st Armored Division coordinated attacks across 50 miles. Crews who had never met coordinated maneuvers warned each other of threats and called artillery with crystal-clear FM communications. German intelligence noted the clarity, but attributed it to training, missing the technological gap. By September 1943, in Italy, mountainous terrain should have nullified radio advantages. Instead, Shermans thrived while German radios failed entirely. Frequency modulation overcame multipath interference in valleys, allowing tanks separated by ridgelines to coordinate attacks with a precision German doctrine considered impossible without visual signals. June 6, 1944, Normandy. Shermans maintained contact with naval artillery support, impossible for German forces. Initially, tank radios were incompatible with infantry SCR-300 units, operating on 40 to 48 MHz. Field improvisations like EE-8 field telephones, mounted on tank exteriors, solved the problem, and by Operation Cobra, over 200 Sherman tanks operated as a unified network. German defenders faced tanks that seemed omniscient. Artillery strikes arrived within minutes, and threats reported miles away were met instantly. The strategic contrast was stark. Panzer divisions lacked full communication. Most tanks relied on visual signals within 100 meters. Few functioning radios suffered interference, and even when present, German doctrine failed to utilize them fully. Heinz Guderian, architect of Blitzkrieg, had stressed radios since the 1920s, but by 1943, production shortages rendered doctrine impractical. Only a fraction of German tanks had transceivers, while all American Shermans had FM radios. March 1945, Remagen Bridge. American communication superiority enabled rapid exploitation. When the 9th Armored Division found the bridge intact, radio reports reached headquarters in minutes. German forces, reliant on destroyed telephone lines, could not react. Tanks from multiple battalions coordinated seamlessly, and counterattacks arrived piecemeal. April 1945. Encirclement of the Ruhr Pocket. American forces executed complex double envelopment entirely through radio networks. 325,000 German troops trapped, unable to communicate. American air controllers targeted German communications systematically. Field Marshal Walter Model's final messages reflected chaos. No contact with adjacent units, no command structure. Psychologically, the impact was profound. American crews fought knowing they were never alone. German crews fought isolated. Otto Carius, a prominent panzer commander, noted the difficulty of coordination but did not fully grasp the technological gap. Across France and Germany, Sherman crews operated as a networked entity, while German tanks remained fragmented individuals. Production statistics underscore the achievement. Over 50,000 SCR-508 radios produced, everyone installed in 49,324 Shermans, 100% deployment. German FUG-5 transceivers, 6,000 units for 12,000 medium tanks, full deployment 20%. Transmission power 25 watts versus 10 watts. Range moving 7 miles versus 0.5 to 1 mile. Frequency stability plus or minus 0.01% versus plus or minus 1%. The lesson is timeless. The SCR-508 radio turned the Sherman from a medium tank into a node in a networked weapons system. Coordination and connection outweighed armor or firepower. Across North Africa, Italy, Normandy, and Germany, American communication superiority determined the battlefield. The Wehrmacht discovered too late that every Sherman was part of an unprecedented network, proving that in modern warfare, connection defeats isolation and information supremacy eclipses platform superiority. Every Sherman tank wasn't just a vehicle, it was a node in the first true battlefield network. Radio technology allowed American crews to communicate instantly, coordinate attacks over miles, and respond faster than any German unit could. While Germans relied on isolated tanks and visual signals, Americans fought as a connected force. The war's outcome, in armored engagements, often came down to who could communicate, coordinate, and control the battlefield. December 18th, 1944, 06:15 hours. Near the town of Bullingen, Belgium. Obersturmbannführer Karl Richter wiped a thin layer of frost from the hatch of his Panther command tank. The engine beneath him coughed, then abruptly fell silent. A moment later, one of his mechanics climbed up, breath turning to steam in the frigid air. Herr Obersturmbannführer, the reserve tank is dry. 3 days into the Ardennes offensive, Hitler's last great gamble, Richter's spearhead, was dead on a lonely Belgian road. To his front, the route to the Meuse River stretched another 50 miles. To his rear, more than 80 armored vehicles, Panthers, Panzer IVs, Sturmgeschütz assault guns, sat motionless, their crews anxiously staring into the mist. They hadn't been defeated by American firepower, they were defeated by empty fuel tanks. Then came the sight every German officer had prayed for. A captured American convoy of fuel trucks parked near the crossroads, abandoned in a hurry. The white stars painted on the tanks looked almost like a mockery. "Bring the fuel drums forward, now," Richter ordered. Men rushed forward, cracking seals and inhaling the sharp odor of high-octane American gasoline, more refined than anything Germany had left. Within minutes, fuel began flowing into the German tanks. Engines that had frozen back to silence now roared to life again. A steel beast awakened by enemy lifeblood. Richter walked down the line, counting barrels, gauging hope. 3,000 gallons. Enough to move his column another 15 miles. Maybe. For a moment, morale surged. Mechanics slapped tank armor with renewed confidence. Officers unfolded their maps, calculating fresh advances. Richter stared at the American trucks. Still warm. Coffee cups inside the cabs, half full. But the triumph lasted only seconds before the truth crept in. Cold and devastating. If the Americans could simply abandon such quantities of fuel, if they could drive full trucks forward, then walk away, then Germany wasn't just running out of gas. Germany was running out of time. Months earlier, Albert Speer had warned Hitler that synthetic fuel plants were burning under unceasing Allied bombing. Production fell from 175,000 tons in April to under 10,000 by fall. Luftwaffe training hours were cut to nearly nothing. Surface ships sat rusting in port. Meanwhile, United States oil production in 1944, 1.8 billion barrels. Germany, including Romania and synthetic fuels, 33 million barrels, less than 2% of American output. The Germans were trying to conduct mechanized warfare with an army fed by horses. Richter's men had captured what for them was a rare treasure. For the Americans, it was 1 hour of supply. Across Belgium and Luxembourg, the US Army had built a petroleum empire. Pipelines pumping fuel straight from Normandy beaches, a fleet of 16,000 trucks, Red Bull Express, running non-stop, millions of gallons at every rail junction, every crossroads. If threatened with capture, burn it all. American engineers would torch 2 million gallons at a single depot without hesitation, the plume of black smoke visible for miles, simply to deny it to Germany. To Richter and his men, it looked like burning victory. As his tanks resumed their advance, Richter sat with the fuel ledger in his lap. Consumption per Panther in combat, 1.8 gallons per mile. Distance to Meuse, 50 miles. Fuel remaining after this seizure, 15 miles at best. The math wasn't war. It was a death sentence, written in liters. He had spent years believing Germany was technologically superior, stronger, destined. But watching American gasoline surge into his tanks, he saw a horrifying contrast. Germany celebrated capturing 3,000 gallons. America mourned losing 3 million. He looked to his crew, hungry, exhausted, hopeful. They didn't yet know, but Richter did. The battle might still rage. The shells might still fall. The tanks might still advance a few miles more. Yet the war was already lost. By December 20th, Richter received the order every German tanker dreaded. Conserve fuel. Do not maneuver unless absolutely required. Tanks became artillery pieces on tracks, stationary giants with empty bellies. Crews siphoned fuel from wrecks just to run generators. Officers argued over cups of gasoline. American units surrounding them received daily allocations larger than the entire German offensive reserve. One US lieutenant remarked in his journal, "The Germans run out of fuel. We run out of places to store it." On the night of December 23rd, with Allied aircraft overhead and fuel completely gone, Richter gave his last order. Abandon the vehicles, destroy what we cannot carry. The Panthers, symbols of German power, were blown apart by their own crews. Millions of Reichsmarks left as molten wrecks on cold Belgian roads. Richter walked away with only a pistol, a map, and the truth. He had not encountered a stronger army. He had encountered a stronger nation, one whose factories and refineries fought with far greater power than any tank battalion. America could fight on fuel. Germany was fighting on fumes. Hitler believed willpower would win. But the world's first truly mechanized war had a different law. Whoever controls the oil controls the war. And that December morning in Belgium, watching American fuel flow into German engines, Obersturmbannführer Karl Richter knew Germany had already lost. The events of December 1944 in the Ardennes, often overshadowed by tales of bravery and combat, reveal a far deeper truth about the nature of modern industrial warfare. That logistical superiority, not tactical skill or individual heroism, determined the outcome of World War II. The German Ardennes offensive, led by officers like Obersturmbannführer Karl Richter and SS Oberführer Joachim Peiper, was fatally constrained by a critical lack of fuel. Despite the skill, training, and experience of German soldiers and crews, their mechanized advance, the spearhead of Hitler's last major offensive, ground to a halt, simply because their tanks, half-tracks, and assault guns had no gasoline to run. The contrast with the American forces was stark and decisive. While German units carefully rationed every liter, their enemies operated with a level of abundance beyond comprehension. The Americans built a logistical network capable of delivering millions of gallons of fuel daily, utilizing pipelines like Operation Pluto and the Red Ball Express trucking system, ensuring that armies in motion were never limited by supply. When confronted with the possibility of capture, American engineers burned fuel depots worth millions of gallons rather than let the Germans seize them, an act that highlighted both the scale of Allied resources and the impossibility of German assumptions. A single depot's 2 million gallons destroyed in Stavelot would have fueled an entire German division for weeks, yet for the Americans, it was a fraction of their reserves. The Ardennes campaign underscores that industrial production and logistics had become the ultimate instruments of warfare. German reliance on synthetic fuel, devastated by Allied bombing, left the Wehrmacht incapable of sustaining mechanized operations. Conversely, the United States produced oil and war materiel at such a scale that shortages were almost unimaginable, and even losses or destruction could be absorbed without strategic consequence. Every calculation, every decision, and every action of the German forces was dictated by scarcity, while their opponents operated with inexhaustible abundance. The psychological impact of this imbalance was just as profound as the material one. German soldiers and officers, long convinced of their technological and tactical superiority, witnessed firsthand the sheer scale of American industrial power. Capturing thousands of gallons of fuel at Hansfeld, what seemed like a miraculous windfall, quickly became a bitter reminder of the futility of their efforts when compared to the millions of gallons Americans could consume, deliver, or destroy at will. Operational decisions, movements, and even atrocities like the Malmedy massacre were influenced by desperate attempts to cope with fuel shortages. By the time German units were immobilized and abandoned their tanks on December 23rd, the truth had been made undeniable. The war was lost, not through battlefield defeat alone, but through the overwhelming industrial and logistical superiority of the Allies. The Ardennes offensive thus stands as a defining example of how modern warfare is dictated by supply chains, production capacities, and the management of resources rather than the skill of generals or the valor of soldiers. German tactical prowess, while formidable, could not overcome the structural limitations imposed by fuel shortages and industrial insufficiency. Meanwhile, the Americans, operating with unprecedented abundance, could absorb losses, burn resources to deny them to the enemy, and continue offensive operations with little constraint. In the end, the story of Hansfeld, Stavelot, and the frozen Belgian roads is not just a story of tanks and soldiers, but a lesson in the reality of industrial warfare. Victory favors those who can produce, transport, and expend resources at scale. The Tiger tanks abandoned in the Ardennes, their fuel gauges empty, stand today as monuments to the point when Germany's tactical skill met industrial inevitability and lost. It was a war decided not in courage or blood alone, but in barrels of oil, tons of steel, and the ability to sustain the machinery of battle. A lesson that echoes in every conflict where industry and logistics define the front lines as decisively as bullets or bombs.